Good afternoon, and thank you for joining us for the first presentation in a multi-part webinar series by the newly formed Ontario Swine Research Network. My name is Hannah Golightly, and I'm a second-year veterinary student here at the Ontario Veterinary College who has been assisting with the OSRN activities. The OSRN has been formed by faculty at the University of Guelph and representatives from Ontario Pork, OMAFRA, and the swine veterinary community. The goal of the network is to enhance and improve the timeliness and accuracy of U of G research results and activities to end users. We also aim to highlight the ongoing collaborative work taking place with other institutions and research partners in order to capture the provincial, national, and international impact of the U of G swine research program. We intend to provide a platform where producers, veterinarians, industry, students, and others can go for current and archived research results. Our new website is currently under development, and we hope to launch it soon. This afternoon, I am pleased to introduce today's speaker, Peter Park. To give you just a bit of background, Peter successfully defended his master's degree through the Department of Animal Biosciences and Toxicology here at the University of Guelph less than 2 weeks ago. Congratulations, Peter. While working on his master's, Peter also competed and won the university's 3-minute thesis competition while representing the Ontario Agricultural College. Finally, Peter looks forward to beginning a PhD in animal science this May at the University of Alberta. With that, I will turn it over to Peter to take you through his presentation entitled Intestinal Binding Agents as an Alternative to Castration and Controlling Boar Taint.
Thank you for that royal introduction, Hannah. All right, so I was talking with researchers at Aarhus University in Denmark actually about this specific topic, what I've been researching for the past 2 and a third years. This past weekend, and it really comes to show, it's really cool that, there's other people in other parts of the world that's looking into the same thing, despite this area in particular being very novel, and it just comes to show I think we need more international collaboration like this whenever possible. But without further ado, I will be talking about, when it comes to the agenda of this presentation, I'll firstly be talking about castration and all of its implications and alternatives. Follow that by a possible control of boar taints using a nutritional method, something that really hasn't been looked into in previous studies. And after that, I'll conclude the slides with what we're looking at when we're looking forward and the future potential that it may have within this area of phasing out surgical castration and what we know and what we don't know. Without further ado, let us go to the main parts. Castration, specifically surgical castration, is at this time, not just within North America, but worldwide, the status quo method to reduce aggressive behavior as well as to prevent what we call boar taint. Boar taint is an unpleasant odor and taste, something that it smells like urine or feces or sweat or a combination of all of them that people have reported. It's not very good. That can be picked up by some consumers upon cooking pork from entire male pigs. We call them boars. And it is caused by an excessive accumulation of two compounds produced in the pig called skatol and androstenone. Skatol, or 3-methylindole in its chemical terms, is a breakdown metabolite of the amino acid tryptophan, and it is facilitated by gut bacteria that resides in the hindgut of pigs. Androstenone, or 5-alpha-androstenone, is a testicular steroid produced in large quantities at time of sexual maturation of the boar. Castration, however, poses implications on both performance as well as animal welfare. If we were talking firstly about performance, if we were to put things into perspective, if you compare boars with castrates, about 8 to 14% increase in feed efficiency is seen. In addition to that, 4 to 20% increase in carcass leanness is also seen, which is beneficial for the increase in premiums for the producer when it comes to shipping off their pigs and to the slaughterhouse. And these are from previous studies that have conducted primarily in the European Union and have used different breeds of pigs as well as different lengths of studies to really look at these attributes. And there are other advantages, both in terms of meat quality and performance when it comes to raising intact males. I'll touch on that again a little more later on, but we'll be focusing on the implications at this time. It also poses implications on animal welfare. Specifically, the European Union has been spearheading an initiative in which they have declared 2018, so this coming year, as a long-term goal year to phase out surgical castration altogether by the 1st of January. However, this is a voluntary declaration. According to the official documentation, it is up to the member states themselves to put pressure in on their industries to phase out surgical castration altogether. And so 2018 seems to be an unrealistic goal at this time. However, it definitely has exerted some sort of pressure and awareness, as evident by the attention picked up from the public when it comes to asking about where our food comes from and how they are treated in farms. Closer to home, in Canada, they updated code of practice for the care and handling of pigs. As of this past July, castration that is performed at any age must be accompanied with analgesics. And therefore, at this time, looking for effective alternatives to surgical castration is a hot topic of interest. Currently available alternatives to castration include genetic selection. The organizations responsible for that is working on it, but it's selecting for low-bore taint lines. Also, slaughtering at an earlier age, this correlates with a lighter body weight. Immunocastration, which is an anti-gonadotropin-releasing hormone vaccine injected twice within a pig's lifetime. And it is marketed as Improvest here in Canada by Zoetis, and is used to shut down testicular function and suppress testicular steroidogenesis. Finally, dietary means are available when it comes to lowering production of skateol in the hindgut, specifically using dietary fibers such as sugar beet pulp, raw potato starch, and chicory inulin. Now, dietary means to influence concentrations of androstenone. That is a very novel area in itself, and it hasn't really been looked into, and that's where my thesis comes into play. Although it is still a work in progress, I believe that there is potential in this becoming possibly an effective alternative to surgical castration. Before I go on any further with regards to my specific research, it is essential that I introduce everybody to this concept called enterohepatic circulation. It's a recycling mechanism that is found in animals, including humans, as well as pigs. In a sexually developing or a mature boar, if I were to break this down step by step, testicular steroidogenesis takes place, obviously, in the testes, as I've stated, and it exerts their effects throughout the body after being transported through the bloodstream. We call it the systemic circulation. Now, there are times when the concentrations of these sex hormones can go up to a certain level whereby it may produce adverse effects, unwanted effects within the body, and so the body employs a specific excretion mechanism that takes place primarily in the liver. And what happens, a crucial step that happens is conjugation, which is steroid, which binds with a sulfate molecule that is highly polar. This means more water soluble. This creates altogether an overall compound, a sulfo-conjugated steroid that is very water soluble in comparison to a hydrophobic steroid, which allows it to be excreted outside to the small intestine through bile, and in the small intestine it has one of two fates. The first, accomplishing the original objective of getting rid of levels, excessive levels. This happens through defecation. However, there is a second fate that exists in which there is certain gut bacteria that resides in the small intestine, which can deconjugate this compound and allow it to be reabsorbed back to systemic circulation. Now, I am proposing, our laboratory is proposing an interruption of this pathway, specifically the reabsorption step. We know that steroids such as estrogens and testosterone is confirmed to go through the cycle. However, androstenone has not yet conclusively been confirmed to go through the cycle. However, we do have a very strong idea that it does based on what we know about other steroids. And so one way to interrupt this specific step is the use of binding agents, also called adsorbents. Binding agents are used for centuries for therapeutic as well as pharmaceutical uses, specifically cholesterol-binding drugs. That is one familiar example. You take it and it binds cholesterol in the small intestine that has been excreted through bile and ultimately lowers the blood concentration altogether. They come from a diverse range of natural and synthetic origins and feature various physical properties which provide their binding capabilities. Now, the use of binding agents have actually been used in our laboratory to treat boar taint in boars. Specifically, we tested Yorkshire boars. And so, if I were to go through this graph of a previous study that we conducted, this red dotted line signifies 1 micrograms per gram of fat androstenone. Now, this signifies the upper limit of a generally accepted threshold level of androstenone boar taint, which means that if the fat androstenone concentration is above this line, people who are able to pick up boar taint will be able to pick it up. And so we supplemented a specific diet that has been formulated to meet NRC 2012 requirements with 5% activated charcoal. What activated charcoal is, it's a black powderous substance that you would find in your Brita filters. And it's also used to treat drug overdoses in humans as well as animals. And so upon supplementation of this and feeding it for 28 days, 4 weeks, to Yorkshire boars, there was a significant decrease in fat androstenone concentrations below this threshold concentration cutoff. And upon taking them off of that diet and reverting it to a diet free of this additive, we, as we expected, saw a significant increase back to above threshold concentrations. Now, this is a demonstration of a proof of concept. However, we did not pursue further with activated charcoal because it is expensive and it's difficult to handle. It really goes all over the place and it really puts your boars looking all over like that. And so we didn't decide to continue on further. And so we needed to look for other alternatives, other alternative adsorbents that we can look into that can achieve similar results to what we have seen in this particular study. How the research within my area progresses, and a lot of other science as well, is you conduct laboratory analyses in the beginning. So you would do simple experiments consisting of simple environments, a simple buffer environment per se, to determine the effectiveness of a particular adsorbent to a specific compound that we're interested in this case androstenone and skatol. Upon producing positive results, we would advance to animal trials, which directly measure the concentration of what we are interested in, as well as measuring the performance to see if these specialized diets do not compromise performance of these pigs. This leads ultimately to my objective, and it was to identify and investigate the effects of mineral-based adsorbents on the levels of androstenone, skatol, and plasma and fat, secondly, growth performance, and finally, carcass characteristics of finished or intact male pigs. And so we needed to look for other adsorbents, and we were able to come up with 4 with what we had available. So if we were to go through this one by one, bentonite firstly is a phyllosilicate clay, which is of volcanic origin and has previously been used in the animal feed industry as an anti-caking agent as well as filler for premixes. Diatomaceous earth is comprised mainly of amorphous silica made up of fossilized diatoms, and it has been previously been used as a filtrate for various liquids in food processing industries, as well as insecticides. Spent filtrate actually is diatomaceous earth, although it is a co-product. It's a waste product of the corn syrup processing industry, and therefore, within its actual surfaces, it has nutrients rich in crude protein as well as fat, making this a possible alternative feed ingredient for animals as well. Finally, hydrated sodium calcium aluminosilicate, we abbreviate it as HSCAS, is another clay-based compound, also known as zeolite, has been previously been used as an antifungal and anti-caking agents in feed. And so using these adsorbents, we needed to determine these adsorbents, the inclusion level, how much to actually include it in grower finisher diets. So what we used was a combination of what we produced in vitro, in the laboratory, the results that we were able to obtain, and guidelines that are provided to us by the Canadian Food Inspection Agency for another purpose, specifically as anti-caking agents. Now, they're not actually used as recommendations for boar taint binding agents because that has not yet been proven. We also needed to choose the specific breed of pig to test, and we decided on purebred Durocs. This is because they are known to have a higher incidence of boar taint based on previous cell culture and live animal studies, and so we thought we were going to be able to detect significant differences much better. And therefore, purebred Durocs were selected as suitable for a proof of concept study. All in all, the first trial that we did conduct consisted of 90 purebred Duroc intact male pigs that were housed at Ponsonby General Animal Facility here in Ontario with an initial body weight of 83 kilograms and initial age of just over 4 months. These pigs were randomly allocated to one of 6 pens, so per group it had 6 pens in total in a complete randomized block design with 3 pigs housed per pen. Upon determination of the individual inclusion level of these diets, we were able to come up with 5 total diets. Firstly, the one being the control, which was a simple commercial corn soybean meal-based diet formulated to meet NRC 2012 requirements. And all others were diluted based on that diet with these inclusion levels of these adsorbents. So these were as follows: 2% sodium bentonite, 3.5% diatomaceous earth, 15% spent filtrate, and finally 0.7% HSCAS. 18 pigs were in a group, and these were fed respectively for 28 days after a 3-day acclimatization period to get the pigs adjusted to the new environment and new pen mates that they had. And for another 14 days, this was deemed the recovery period in which all pigs were reverted to the commercial control diet. And after that, in a span of 3 weeks, all pigs were slaughtered here at the meat laboratory at the University of Guelph. Specific endpoints that we measured and collected from the pig included plasma taken from the blood from the orbital sinus to analyze androstenone through enzyme-linked immunosorbent assay. We also looked at androstenone after taking a back fat biopsy. This was done at the same time points of sampling with the blood to measure fat androstenone with the same ELISA method and Skatol using high-performance liquid chromatography. Other endpoints included weekly weighing of these pigs to calculate average daily gain, average daily feed intake, and feed conversion ratio. The data sets for back fat and plasma concentrations were logarithmically transformed to normalize the data, and all measurements were analyzed for statistical significance, given that p-value is below 0.05 using the mixed procedure in SAS version 9.4. I would like to first disclose results on the performance of this first trial that we conducted. All the pre-slaughter measurements that we analyzed, they weren't different between groups based on the ANOVA that we analyzed, except the age at slaughter. The control group was older than the other groups because of the fact that these pigs were slaughtered based on heaviest to lightest body weights. And so within each kill day of those 3 weeks span of slaughters to kill all 90 pigs, they were not balanced between groups per day, and therefore much of the control pigs were actually left behind. And that is one thing that we should consider really revising for other trials that may ensue after. When we're looking at specific performance parameters, none of them, the growth, the feed intake, or the feed conversion ratio differed between treatment groups, which signifies that giving pigs, intact male pigs, these diets at these inclusion levels for 28 days, a short-term period, do not appear to compromise their performance. Now I'll be disclosing each individual biochemical metabolite, specifically being androstenone in this case, for both plasma and fat. What you should really take out of this, the y-axis is either androstenone concentration in plasma in nanograms per milliliter or in fat in micrograms per gram. The x-axis is the day of trial, and the gray dotted line signifies the end of the treatment period and the commencement of the recovery period. But what you should really take away from these graphs is that there's a lot of variation that we did not expect from these pigs. And so we were wrong about our assumptions regarding the purebred Duroc being an ideal suitable candidate for a proof of concept study when it comes to measuring Bortings. The horizontal error bars that you see at the last 2 time points is because of this staggered slaughter schedule, as I've stated before. But all in all, there were no time or diet or time by diet treatment interaction effects that we saw in plasma androstenone. Fat androstenone is a little bit different. However, we still come to the conclusion that we weren't able to see a treatment difference, a treatment effect based on these supplemented diets when it comes to ultimately lowering concentrations of androstenone in fat, and that is what we are primarily interested in. There is a significant time effect in that, in comparison to their baseline measurements, the concentrations of androstenone in fat significantly increased over time. However, this does not really help us provide a conclusive evidence as to whether these adsorbents that we tested ultimately lowers bore-taint compounds in the body of an intact male. And so, to conclude, these main points include, again, it did significantly decrease levels of androstenone in both fat and plasma of duroc finisher boars. In skatol, I couldn't report, because it wasn't detected in most boars' adipose tissue throughout the trial, only in fact 1.3 to 2.5%, depending on which upper limit you're looking at, of all boars were above this threshold. And so we needed to look at considerations to refine the study for future studies. Again, firstly, breed differences. We saw that when it comes to steroid hormone synthesis and gene expression, a lot of that must really be looked into further. And also factors associated with pubertal onset is multifactorial. The genetics and the breed, age, body weight, nutrition, and social environment all play a part. And so we also thought inclusion level, maybe it might have been too conservative, and so we needed to look at other detailed toxicological studies in other species if we have to really look into what exactly we need to have a correct amount, while also looking at duration of the feeding. How long should we be giving these treatment beats? A diet added with an adsorbent for a cost-benefit analysis that should be run in the future. Very quickly, if we were to examine the meat quality, there was a follow-up trial using crossbred boars. We saw no differences in carcass meat quality parameters based on the subjective and the instrumental measurements that we tested when it comes to carcass and loin quality. And this, with the exception of firmness and intramuscular fat, these parameters actually was a significant decrease. We used spenfiltrate and HFCAS one more time and compared with control using crossbred boars. For firmness, there was a significantly lower score for the ones that were fed starting at for a longer duration. So 70 means it was fed for a longer duration, starting at 70 kilograms. In comparison, 90 started at 90 kilograms and fed up to slaughter. When it comes to intramuscular fat, the ones that were fed spenfiltrate had a significantly decreased level or measurement of intramuscular fat. If we were to take away something from this, some of the tested adsorbents, we can say that it can appear, it's suggestive to influence fresh pork firmness if fed for a long period of time. However, influence of intramuscular fat, this does not equate marbling, by the way, is multifactorial. The back fat thickness, ad libitum feeding, genotype, and dietary protein content all play a part. If we were to wrap everything all together, keep in mind that boar taint is influenced by many factors, including hormonal status and genetics. And only a bulk of the population, a handful of the population can pick it up, and everyone has their own definition of boar taint. It's very difficult to interpret and compare between these studies. Diets added with the ones that we've tested, these mineral adsorbents, do not appear to compromise the performance, but may influence some meat quality characteristics if fed for a long period of time. Now, you might be asking, in the grand scheme of things, what did you actually accomplish over your thesis? Because if you saw null results, what are you going to do? What's the next step? Well, another trial has just conducted, and we use crossbred. So this being Yorkshire Landrace dam crossed with a duroc sire. These boars were used this time, and we also use barrows in this case for direct comparisons of boar taint levels. We also fed them from 70 kilograms and slaughtered at 130 kilograms. We abandoned the idea of the recovery period altogether. We also measured other things like the reproductive tract, as they are indirectly correlated with boar taint. And we also need to look at further assessments of meat quality. We need to reproduce the results that we had, and so we will be evaluating the loin and the bacon, as well as recruiting specific taste panels. Putting everything into perspective, I want to introduce everyone to the idea. It's something to think about. It's not yet further advanced. We're not at this point yet, but it's something to think about. The potential benefits of raising intact males. For the producer, obviously it has increased premiums and decreased labor costs that have been found to be appealing for many years now. And for the consumer, it can provide leaner, bigger, and healthier pork, because we know that there is an increased ratio of polyunsaturated fatty acids in pork from cuts of intact male pigs. For the legislator, finally, it can provide elevated standards of animal welfare for other jurisdictions to follow. And definitely all three are definitely something to think about, despite this work being still a work in progress. which we are still looking at really further to see whether this can be a feasible alternative to castration. With that, I hereby state my acknowledgments. Just very quickly, my advisor and my advisory committee members, as well as my funding agencies that have made everything possible. I know that this is a post, this isn't a live recording, and so if you have any questions, please forward it to the facilitators of the Ontario Swine Research Network, so that they can forward your possible questions to me, and I will definitely be able to provide you with an answer. It's a bummer that I didn't get to actually stand and take your questions real time, but I guess with technical difficulties comes with these hurdles. With that, I say thank you very much, and if you have any more information, please contact using the information provided on this slide. Have a nice day.
Thank you very much, Peter, for that great presentation. Thank you, everyone, for watching us in this presentation. And please watch your email for our next webinar, which will take in March 2017, so next month. And as Peter said, if you have any questions, please forward them to the Ontario Swine Research Network. You can forward them to Terry O'Sullivan, and her email address is there. Thank you, and have a great afternoon.